Hello class, this is Mr. Sutton, and today we're going to be talking about Intro to Logarithms and log properties. So here's some notation for you to write down for your notes. So first thing I want to point out, this is log notation. So the b down here is the base. If you rewrite it into exponential notation, so let's say this is log notation. Over here on the other side of this double arrow is exponential notation. B is the base. X by itself on the other side of the equal sign is the exponent. So the log always equals the exponent. And then A right here, that's the answer, we'll call it. So you want to be able to rewrite log notation into exponential notation. Another thing to point out, log base E is the same thing as ln, which is called the natural log. And E is just an irrational number and a common base that we use for logarithms because it's commonly used for exponential functions as well. It's just an irrational number between 2 and 3. Another thing I'll point out, if a log doesn't have a base written, that means it is an invisible 10. So log with no base is the same thing as log base 10. Okay? So those are some things to make sure you have in your notes. Now, I want to go through these problems on Delta Math because I want to show you how to use the calculator for these. But there's a couple different ways to approach these. First one, we're just evaluating logarithms. So no equation here. We just have log base 2 of 64. We want to figure out what that equals. So one way to approach this is to create an equation and then rewrite it in exponential form. So this would be 2, and then x is our exponent, equals 64. So now we can see, if you're not sure about the log notation, when it's in exponential form, hopefully you can see it's 2 to what power equals 64. So you can solve that by inspection or by guess and check, checking a couple different things in your calculator. Like, let's say I start with 2 to the 5th power. That equals 32. So I'm going to have to multiply by 2 again. So let's try 2 to the 6th power. Okay, and that's it. So 2 to the 6th power equals 64. So that is one way to do it, just checking some things in your calculator. Another way you can do it, and I guess I should have showed you on this calculator. So 2, and then this is your exponent button to the 6th power. You can see equals 64. So another way you can do it is, the thing about the log button on your calculator is it only does log base 10. So if I try to do log of 64, it's going to tell me the base 10 of that. So it doesn't give me 6, it gives me the wrong answer here. But what I can do is this log base 2 of 64 is equivalent to log base 10 64 divided by log base 10 of 2. So if I take that 2 and put it in its own log base 10 in the denominator, I can get the right answer that way. So I'm going to do that log, and then that's another base 10, and I put a 2 in here, and then now all of a sudden we see that this equals 6, which is the same answer we got up here. So if you are stuck on one, if you're trying guess and check and you're not getting the right answer, you can always do this method where you rewrite it as 2 logs being divided by each other. So, and it has to be base 10 just because that is what the calculator automatically does. But you put the 64 in the top log, and then you put the base here inside the bottom log, like that, and that will give you the right answer. So I'm going to go ahead and put in 6. And I got the answer that way. Okay. And for this one, the way they give you feedback on Delta Math is they just explain the guess and check. So 2 to what power is 64, and that would be 2 to the 6th power. So here we have what is the value of log base 4 of root 5, the 5th root of 4 to the root 5th, I guess you could say. So I have that rewritten over here. I want to change this to exponential form, so I want to create an equation here. And before I do that, I also want to rewrite this instead of as a radical, rewrite it as 4 to the 1/5 power, because we know that radicals are the same thing as fractional exponents. So root 5th is the same thing, the 5th root is the same thing as 1/5 power. So that'll make it easier to rewrite this as an exponential form. So our base is 4, right? Base is 4, x is our exponent, equals, and then our answer here is 4 to the 1/5. Now we can see that for these to be equal, these exponents have to be equal as well. So x equals 1/5. So that would be our answer here, 1 divided by 5. All right. So here we have log base 25 of 125. So we want to set that equal to x, rearrange it into exponential form. So base 25 to the x power equals 125. So 25 to what power equals 125? I'm thinking I'll start with just 25 squared. 25 squared equals 625. Yeah, so squared is already a lot, so we're going to have to do some fractional exponents here. So let's see, maybe 3/2. Okay, yeah, and that was it, so 3/2. So I knew it had to be somewhere between 1 and 2, because if you do something less than 1, like if I did 1/2, that's we start getting answers smaller than our original number. So it's got to be something bigger than 1. So 3/2 was the answer. And again, if you're struggling with the guess and check, what I recommend doing is plugging into your calculator as log base 10 of 125 over log base 10 of 25. And let's see, I'll show you that. We should get this 3/2 answer that way as well. So log of 125 divided by log of 25. Yeah, and 1.5, which is the same thing as 3/2. So 3. Okay. The way they show this, actually, which is another way to approach this, which I didn't think about, but is a good method here. What they do is from this step here, go back to that step, paste that. is they then rewrite the 25 and the 125 with a common base. So instead of 25, they write it as 5 squared x, or 5 to the 2x power. And instead of 125, 5 to the third power, 5 cubed. Now we can rewrite it with the exponents. If these exponents equal each other, if these things equal each other, that means the exponents also have to equal each other. So then we can divide by 2 on both sides, and x equals 3/2. So that is another way, a third way you can get the same answer. So let's try another one using that common base method that they showed in Delta Math, because I like that. So we want to evaluate log base 64 of 1/16. So I'm going to rewrite this in exponential form. So 64 some power equals 1/16. And I'm thinking they have a common base of 4, actually, of 4. Because 16 squared is already 256, so much bigger than 64. But 4 squared is 16, and 4 to the third power is 64. So we can do that. 4 to the third x. And then this would be 1 over 4 squared, which we can rewrite as 4 to the negative 2 power. And then if these equal each other, then the exponents have to equal each other as well, because we have the same base now. So that would be 3x equals negative 2. Divide by 3 on both sides. You get x equals, it's bad x equals negative 2/3. Which I can check again on the calculator using that method we talked about before. This has to equal log base 10 of 1/16 over log base 10 of 64. Divided by log of 64. Yep, and that is negative 2/3. So you definitely want to write this as a fraction, though. I'm not sure. I doubt Delta Math would accept negative 0.666, because you'll have to round that, basically. Won't be as exact of an answer. All right. So here are some other logarithm rules. We're going to go back to taking notes for a second before we go back to some examples. So here are your logarithm rules. Make sure you get these down in your notes, and we'll talk through them a little bit. This first one here, we have log base A. If we have two numbers in the argument is basically what goes in the parentheses. If we have two numbers here, or two values that are multiplied by each other, we can separate them into two logs added together, or we can go the other way. If we want to combine them into one log, we can multiply those two arguments together inside one log, or separate them as two separate logs added together. And that comes from the idea, if I basically have 5 like to the second power multiplied by 5 to the third power, when I multiply these together, I add the exponents together, right? So that becomes 5 to the 5th power, right? So that is where the idea comes from of these being multiplied together, is the same thing as adding the exponents together. Same thing here, when we have the argument is two numbers being divided, we can separate those into two logs being subtracted. Or if we have two logs subtracted, we combine it into one log where we divide the arguments. And that's basically the same idea we had before with exponents. If I have 5 to the 5th divided by 5 to the 3rd, that equals 5 squared, right? Where I am subtracting the two values, right? Same thing as 5 minus 3 in the exponent. Another thing is if you have an argument value raised to an exponent, you can bring that exponent out in front and multiply it. And that comes from, if I have 5 squared, if I raise that to another power, I'm multiplying two exponents together. Right, so that's where that rule comes from. You can move that exponent out in front and turn it into multiplication. Or if you have a number out in front, you can make it become the exponent within your argument. And then this rule is the same rule we applied before to use the calculator. If you have a log of the same log of one base, you can turn it into a division problem with the log of the same base here, with some other base, usually 10, because that allows you to put it in a calculator. And then you just move this into your argument up here, and then your former base goes into your argument in the denominator. And then we have this last one. If you want to switch the bases in the argument, it becomes 1 over, and then B becomes your new base and A becomes your new argument. One thing to note about these first three rules is they all have to have the same base for this to work. Notice that these all have a base of A here. If you don't have the same base, then you cannot combine them into one log, right? Like this only works if we have 5s here. If I had 5 squared multiplied by 6 squared, I have to do those separately. I can't combine them into one exponent. All right. So some things to note for the next section of the practice. I'm going to go ahead, move to, make sure you have those notes written down. So here we want to condense this logarithm into one logarithm. Notice we cannot see the base. So like I said before, that means it's an invisible 10. We assume that these are log base 10. So that means that they have the same base. If they did not have the same base, they would make sure to show us the base if it were something else. So we can condense these into one log. We can go ahead and move the z to the exponent. So we have k to the z power. And then we can go ahead and, since these are being subtracted, turn it into a fraction within the argument. So it would look like this. That was pretty small z. There we go. So log of b divided by k to the z power. There we go. All right. Let's get another one. So for this one, we can move the 8 to the exponent and the 2 to the exponent as well. And then we can combine these, since it's addition, we can combine these into multiplication within the argument. So k to the 8 plus x squared. K 8 and x squared multiplied together in the arguments. All right. Now we're going to work on some ones that are numerical logs. This time we can see that they have a base of b. We don't know what the base is, but we can see that they both have the same base. So we can go ahead and condense these, and this time we're working more with numbers than with variables. So I'm going to move this 2 to the exponents here. So it becomes 3 squared. And then this one does not have a number being multiplied, so this is still just log base b of 6. So I can go ahead and square this. 3 squared is 9. And then now I can combine these into one log where the 9 and the 6 are multiplied together. And 9 times 6 is 54. So this becomes log base b of 54. So I'm going to go ahead and submit that. Okay. So yeah, this becomes 3 squared, which is 9, and then this becomes 9 times 6, which is 54. So now let's look at this one. Here we have a subtraction problem with numerical values. So the 2 we can move to the exponent. So that becomes 4 squared. So we can go ahead and 4 squared is 16. So now since they're subtracting, we can combine these, and since they have the same base, we combine these to a division problem. So that's 16 divided by 2, which is 8. That's not how you write that. No equal sign. 16 divided by 2 is just 8. So that is what goes in the argument. All right. So now we want to look at some expanding log problems. So here we have log x squared divided by y to the third. And we know they have a common base because it's already written as one log. So we can first separate this into a subtraction problem. And then we can also move the exponents out in front. This is basically just the reverse of what we've been doing in the previous problems. So let's see, that would be 2 and then log of x minus 3 log of y. Let's submit that. Good. Here we have a more complicated one. So first thing is to separate the fraction into 2 logs. So that's going to be log x squared y, square root of y to the 5th, and then subtract log of z. And then we can also separate these pieces here. Those are being attached by multiplication, so log of x squared, and then plus log of square root y to the 5th minus log of z. And then now we can deal with the exponents. This one you probably want to rewrite as 5/2 instead of square root y to the 5th. So I'm going to move the exponents out in front now. So 2 log x plus 5/2 log of y, and then minus log of z. Let's see, well, let me just type this, plus 5/2 log of y minus log of z. Yes, it will. So we'll let you just type it. You don't have to push the log button every time. All right, but it's important to do the division first because z is dividing this whole thing, so you have to separate that z first rather than trying to deal with the numerator on its own. You can't separate those multiplications first. You have to separate the division first, right? So that's important to note. If you have any questions about any of this material, make sure you are asking for help during class, and have a good day.